Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will talk to integral test of convergence, ratio test series, and the n-root test and the alternate series test. I had a video previously about other series. I'm gonna put the link of that video in my description. So with those two videos, you should cover most of the series, I guess. So let's start with the integral test of convergence. To be able to use the integral test of convergence, we have to make sure that the series is continuous and it is positive and it is descending. If it meets those three conditions, we can use the integral test of convergence. Let's take an example. Let's show that n equal 1 to infinity of 1 minus n squared. We want to study if it converges or if it diverges. So I know that the denominator cannot be 0, but that series is starting with 1. Yeah, so it is continuous, because if I want to draw it, it's asymptotic to 0 and it's gonna be something like that, but it continue till infinity here and it continue till infinity here. So as long as n greater than 1 or not equal to 1, this series is continuous, and n square is always positive. 1 over a positive number is always positive, and it is descending because for n equal to 1, that series is equal 1 divided by 1. For n equal to 2, 2 to the power of 2 is 4 plus 1 over 4. For n equal to 3 is 1 over 2 to the power of 3 is 8, etc. So it is descending. So it meets all the condition for the integral test of convergence. So let's use that test to study if that series converge or diverge. To see if that series converge or diverge, I have to study the limit using the integral test. I have to study the limit when x goes to infinity of 1 over, instead of saying n2, I'm gonna say x squared because we're more accustomed to that. And I need the integral here. Let me bring this here and take out this and put the integral here. dx. Yeah, I can keep 1 over n2 and dn, but we're more used to x going to infinity and x squared dx. So the integral of this, it is the integral limit for x going to infinity to x minus 2 dx. So which is equal x minus 2 plus 1 is minus 1 divided by minus 1. And if I want to study it between 1 and x, where x is going to infinity, yeah, because we said it is going from 1 to infinity. So x is going to infinity and I'm studying between 1 and x. So it is between 1 and x. So x to the power minus 1, I can put it like that, minus 1 over x between 1 and x. So the first time I will replace x by x here, and then the second time is 1 by 1. So it's minus 1 over x minus 1 over 1, because it's the upper bound minus the lower bound, and the minus 1 is in my my term is minus 1. So it is minus 1. It becomes plus 1. So it is a limit here. There is a limit when x goes to infinity. Limit when x goes to infinity of minus 1 over infinity, or x, plus 1. So when x goes to infinity, 1 over infinity is 0, minus 1 over infinity is 0, so the limit is equal to 1. And since 1 is a constant, we say that this series converges. Which is equal to a constant, this series converges. Let's look at the ratio test series now. Ratio test series. The theory of ratio test series, it said we have to study the limit when let's say n goes to infinity of an plus 1 divided by an. If that limit is less than 1, if the limit is less than 1, we say it converges. If it is greater than 1, it diverges. And if it is equal to 1, it may diverge or conditionally converge or absolute conversion. Absolute conversion. So if it is equal to 1, we cannot know if it converges or diverges. It can be one of those three choices. If it is less than 1, it converges. Greater than 1, that diverges. Let's take an example of a series, that series, n equal 1 to infinity of minus 10 to the power of n divided by 4 to the power 2n plus 1 times n plus 1. Yeah? So this is my a of n here. So I want to see the limit of a of n plus 1 divided by a of n when n goes to infinity. Let's call it like r or l, whatever. Let's call it l for limit. So here I have my a of n is equal to this. That's my a of n. This is my a of n. Let's find my n plus 1. So a of n plus 1 is equal. All what I have to do is replace every n in my series by n plus 1. It's minus 10 to the power of n plus 1 divided by 4, 2 times n plus 1 plus 1 times n plus 1. So that n become n plus 1, and I have plus 1 here. I add it. So this is my n plus 1. So let's write it in a better way. It is minus 10 to the power of n times minus 10 to the power of 1 divided by 4 times 2n plus 2. So I distributed my 2 inside my parentheses. There is plus 1 here multiplied by n plus 2. So 1 and 1 is equal to 2. So now let's find the limit when n goes to infinity to an plus 1 divided by an. So the limit when n goes to infinity, I will start an plus 1, which is minus 10 to the power of n times minus 10 to the power of 1 divided this. I will write it right away. 4 to the power 2n times 4 to the power of 3 multiplied by n plus 2. Because 2 plus 1 is equal to 3 and there is a plus, so I put a multiplication. Divided by an, which is minus 10 to the power of n divided by 4 to the power 2n times 4 n plus 1. So let's write the limit in the middle. Limit when n goes to infinity of this. So this is L equal limit to n goes to infinity. Let's write it the right way. So L equal limit when n goes to infinity. Okay. So I know if I have a division of two fraction, I can flip the denominator and make it a multiplication. So L is equal limit when n goes to infinity of minus 10 to the power of n times minus 10 to the power of 1 divided by 4 to the power 2n times 4 to the power of 3n plus 2. And then I will flip the denominator and make it multiplication. So this is the multiplication sign, times 4 to the power 2n times 4 multiplied by n plus 1 divided by minus 10 to the power of n. And now, since I have all multiplication, I can start simplifying. So let's take another color here. Minus 10 to the power of 10. Sorry, let's take another color so you can see it better. Let's take this color. So minus 10 to the power of 10 and minus 10 to the power of 10, I can simplify it. And here I have 4, and here I have 4 to the power of 3, so it becomes 4 to the power of 2. This becomes 4 to the power of 2. And what else do I have? I do have 4 to the power of 2n and 4 to the power of 2n. And I think that's it. So let's write it down. So L is equal to the limit when n goes to infinity. I have here minus 10 to the power of 1. I'm not gonna write it. Divided by, and this is absolute value here. It should be an absolute value here. So this is an absolute value here. And this is an absolute value here. I realized when I saw the minus 10. So let's start the absolute value here. Minus 10 and time n plus 1. Time n plus 1. Yeah. And here 16. 4 to the power of 2 is 16. This is 16 times n plus 2. Absolute value. I still have n in my limit, so let's factor out n. So the limit equal L is equal to the limit when n goes to infinity of minus 10 times n 1 plus 1 over n divided by 16 times n 1 plus 2 divided by n. Yeah. So let's write it in a better way. Limit when n goes to infinity. I would have minus 10n multiplied by 1 plus 1 over n divided by 16n multiplied 1 plus 2 divided by n. And when n goes to infinity, now let's take the other color here. This goes to 0 and this goes to 0. 1 divided by infinity is equal to 0. Because if you have $1, you want to give it to an infinity of people, you give each almost a 0. And the n here and the n here get simplified, and minus 10 times 1 is minus 10, and 16 times 1 is 16. And because I have the absolute value, my limit is equal to 10 over 16. And if I go here, that limit 10 over 16 is less than 1, so my series converges. 10 over 16 less than 1, it converges. So let's do the third example for the NM root test. For that, we study the limit when n goes to infinity of the nm root of a of n. Let's say that my series is a of n. Let's say the series is equal a of n. If the limit is less than 1, sum of a and n is converge. If it is greater than 1, it diverge. And if it is equal to 1, we cannot determine. Undetermined. So we have to use other tests. So let's start with an example. If I have a series of n equal 1 to infinity of n square plus 3 divided by 2n square plus 5 and all of that to the power of n. Since I have a power n of that series, we can use the n root test. So what I can do is I can do the limit when n goes to infinity. As I said here, if I have that, I can use this, but n to the power of n. I can do the nth root of n square plus 3 divided by 2n square plus 5, and this is n here. Yeah? So to the power of n. And now to the power of n and the nth root disappear, it becomes the limit when n goes to infinity of n square plus 3 divided by 2n square plus 5. And here I can factor out my n square, so it becomes my limit when n goes to infinity of n square 1 plus 3 divided by n square, because if I multiply n square by 1, I would have my n square here, and n square by 3 divided by n2, I got my 3, and same logic here, I put n square and I will have 2 plus 5 over n square, and here n square and n square, I can simplify it, and when n goes to infinity, this goes to 0 and this goes to 0, so my limit will become 1 over 2, and 1 over 2 is less than 1, and we said if it is less than 1, my series converge. So less than 1, it converge. So the sum n equal 1 to infinity of 2n of n square plus 3 divided by 2n square plus 5 to the power of n converge. My final test, it is about the alternate series on that video. So we will talk about the alternate series. The theory in alternate series, let's suppose that we have a series of an, yeah, where an is equal minus 1 to the power of n, hence the alternate bn, or an is equal minus 1 to the power of nn plus 1 times bn, yeah, where bn is greater or equal than 0. So it cannot be a negative number. So if the limit, and I'll give you an example, you will understand better, bn of bn is equal 0 when n goes to infinity, and bn is decreasing sequence, we say it converges. It converges. That's the theory, and let's apply the theory in one example. So let's take the example, and this is, you have to know it like this, is you have to study it. Sum n equal to I'm going from 0 to infinity of minus 1 to the power of n minus 1 n square. So here when I said n plus 1, it can be n minus 1, whatever. And when I said here n plus 1 over n square plus 3. So I can write this series as sum n equal to 0 to infinity of minus 1 to the power n minus 1 times n square divided by n square plus b. So I can have my bn now, because this is minus 1 to the power of n plus 1 or minus 1 or n, and this is my bn. So my bn, b of n, is equal n square divided by n squared plus b. And here I want to make sure that my bn is decreasing and it is positive. But we said like b is greater than 0 and n is to the power of 2. So it's always positive and b is positive in that case. So my series is positive and it is decreasing because the denominator is bigger than the numerator. Whatever I put in the numerator as n, there is a plus b in the denominator. So my series is decreasing. So I can use this alternate series test. I know whatever I'm gonna take n, my denominator is bigger, yeah? So my denominator is gonna be bigger and my bn is decreasing, and the limit of -1 to the power n minus 1 is gonna alternate between -1 and +1, -1 plus 1, depending if n is odd number, it's odd number, -1 it become an even number, it become positive, and if n is even number, even -1 is odd and it become negative. So we know for a limit to exist, the -1 to the power n minus 1 need to have a single number, and we do not know what is infinity, so we're gonna keep on going -1 plus 1 forever, because infinity is infinity. We don't have the infinity, so we keep on going till forever. So it diverges because it does not go to a one number. So the limit should be one constant, and this one does go to minus and plus whatever the number is of n squared divided by n squared plus b. So that series converges. So I hope you like my video. If you do, please subscribe to my channel. That would help me a lot, and you don't have to do anything. Just click on the button subscribe, and they won't ask you username, password, nothing. Like, you click and you subscribe, and this will help me. And if you put a like, I would really appreciate it. And at the end, in the description of that video, I will put a link to other series video that I did. Thank you.